passengers who do not appear on the flight. And looking at this problem, you see that X is binomially distributed with n equal to 200, and P, the probability of not showing up, 1%. So I asked you to use Poisson approximation because n is really large here, and n times P is also large. N times P is small. So you have to calculate lambda, and there's n times P, which is 200 times 0.01, which is 2. That's not bad. And the probability that everyone who appears has a seat is nothing but the probability that the number of people who don't appear. So you have only 198 seats. You've sold 200 tickets. So that means if 2 or more people do not show up, then everyone who shows up can sit, right? Then you have 198 or less number of people who show up. So it's just the probability that X is greater than or equal to. So this is the minus probability X equals 0, minus probability X equals 1 minus e to the negative lambda e to the negative 2 minus e to the negative 2. Some of you, I think, got a little confused and took X to be the number of people who show up and thought that 1% was the probability that you show up. So if you did that, I didn't take off too many points. Given monthly worldwide average number of airplane crashes, commercial airlines 1.2, what is the probability that there will be more than 2 such accidents in the next month? So define your random variable, number of airplane crashes in the next month. And the first thing you need to identify is the distribution, and is this distribution as Poisson with rate lambda. And what is lambda? I've given you the average value of X. Right? I've given you that the average number of plane crashes in a month is 1.2. So I've given you the value of lambda. One way you could think of it, okay, there's several reasons why it should be Poisson. So the real reason is you can think of it as an approximation to binomial. You can think of 1 month as, think of the number of seconds in a month, okay? Or number of hours in a month, say. There are many hours in a month, right? So your n is very large, and the probability of a plane crash in any particular hour is very small. In fact, you don't have to go, you can go down to seconds. Okay, so n is larger in that sense. And the probability that a plane crashes any particular second is very small. So you can think of X as an approximation of that binomial random variable. Another indication why you should have guessed Poisson, I told you there are only 2 kinds of problem. Well, you know the possible distributions you could have. It's not binomial because I haven't given you explicitly n or p. Right? Okay. It's not. Okay, first of all, you can eliminate all continuous distributions. Why? So some of you guessed exponential. Why can it not be a continuous distribution? Look at the definition of X. X only takes discrete values. Okay? So either X could be there are no plane crashes, so X is 0, or there's 1 plane crash, it's 1. So look at the possible values X can take. It's state space. It's only 0, 1, 2. It's only non-negative integer values. So it's only taking values in discrete space. So it cannot be distributed as a continuous distribution. So that should also just leave you with Poisson. All right, so I asked you to find probability that X is, there are more than 2 accidents, probability X is greater than 2, minus probability that X is equal to 0, minus the probability X equals 1, minus probability X equals 2, equals 1 minus e to the negative 1.2, 1.2, 1.2, e to the negative 1.2, 1.2 squared. Part B, define your X as number of fish entrees ordered by next for customers. If you identify this as binomial with n, so you have 4 customers coming. Each customer can either order a fish entree or not. Okay. So n equals 4. Your p is what's the probability of ordering fish? You have 8 fish dishes and order 30 possible dishes. So obviously you have 30. And if you identify this correctly as binomially distributed, then I just asked you for the expected value of x, right? Yeah. The expected value of x is just this formula, n times p, so it's 8, 30, 60 over 50. So it's about 1 point something. So problems 3, 4, and 5, you had problems very similar to these on your normal distribution, in the section on normal distribution and uniform distribution. So I told you you'd have some problems of the type where it's sort of like a compound problem. That is, to find the parameter for one distribution, you'd have to use another distribution to calculate some probability. So you had a couple of problems like that on your homework, and this was of the same sort. Okay. So if you take X as the breaking strength, if yarn picked at random, then you're given that X is normally distributed with mean 95, variance 11 square. First thing to do is calculate what is our random variable of interest. Number of yarn, number of yarn with breaking strength. So in your sample, the number that have breaking strength over 100. So if you look at y is clearly distributed binomially. You have a sample of size 10, and your p you don't yet know. So success is if it has breaking strength over 100, failure is if it does not. Okay. So what is your probability of success? Your little p is basically the probability that any yarn that you pick it has breaking strength of more than 100. So you first need to calculate this, and then you can use that to calculate, what is it that I asked you to calculate? Probability that y is at least 2. So to calculate that, we first need to find little p. All right, so this is normally distributed. We normalize, subtract 95, divide by 11. 5 divided by 11. So this is 1 minus 5, this number, which is 5 over 11. You calculate that, you get 0.3264. So your p here is 0.3264. Probability y greater than or equal to 2 is 1 minus probability y equals 0 minus probability y equals 1. 1 minus, so this is 10, choose 0. Okay, so probability y equals 0, means all that breaking strength over that. It's so if p is that, 1 minus p is 0.6736, 0.6736, 10 minus 10 choose 1, which is 10 times 0.3264 times 0.6736 to 9. Problem 4 was kind of the same type. And it takes time in hours until computer system came, and what we are interested in is number of computer systems out of those 20 that fail before 1700 hours of use. So again, y is binomially distributed with n equals 20, and your little p is the probability that a computer system fails before 1700 hours of use. Probability that x is less than 1700 hours. So x is distributed as, I told you that it's exponentially distributed with the rate lambda. Now I've given you expected value of x, which I know 1 over lambda is 1700. Therefore, lambda equals 1 over 1700. So probability x is less than 1700. That's just the distribution function of x at the point 1700. What's your distribution function for exponential random variables? 1 minus e to the negative lambda x for x greater than 0, 0. So in this particular case, you have 1 minus e to the negative lambda is 1 over 1700 times x is 1700 minus e to the negative 1. You have to calculate probability that if it's more than 1, probability y greater than 1. It's 1 minus probability y equals 0 minus probability y equals 1. It's 1 minus probability y equals 0 is just e to the negative 1. 20 minus 20, 1 minus e to the negative 1, p times 1 minus p to the 19th. Problem 5. Problem 5, you had a problem similar to this, and I did mention that you needed to know conditional probability. So I dropped pretty broad hints about what kind of problems you have on the exam. So what does this problem say? So let x be the height of the vehicle. You're given that heights are uniformly distributed between, okay, this height in feet. Same problem with that. So what's your density function for this? It's just 1 over 14 minus 4, so that's 10, as long as x is between and it's 0 outside that interval. So I have asked you to calculate the probability that so you're given that this vehicle has a special license plate. So that's information that's given to you, so that you condition on. So if you're given that it has a special license plate, what do you know about its height? That it is over 8 feet. So you're given that the height x is over 8 feet. And you're asked to calculate what? That it will be able to pass through the underpass. And the height of the underpass is 12 feet. Okay. So alright, so this is how you set up your question. Once you've set it up like this, you just use your formula for conditional probabilities. This is the probability that x is less than 12 and x is greater than 8, divided by the probability that x is greater than 8. So this is just the probability that x is between 8 and 12, and the probability that x is greater than 8. So this interval, you probably should do the interval 4 to 14. Probability x is greater than 8 is, was it 6 out of 10, right? 6 out of 10. Probability that between 8 and 12, that's 4 out of 10. And so you get this 4 plus 6. All right. That was problem 5. See, Bashir? Last problem. So you're given x is a random variable with density function first step, what are the possible values y can take of y is log x. So if x takes values from 0 to 4, or that is in the interval 0, 4, y equals log x takes values in the interval. So 0 isn't included because at 0 log of 0 is not defined. But as you approach 0, what does log of x approach?
Negative infinity.
Negative infinity, exactly. So this starts from negative infinity, and so log is an increasing function. So it takes every value now from negative infinity right up to log of 4. So this is the range of values that y takes. So now for a y value which is less than log 4, calculate the distribution function of y at this point, y. That is just the probability y is less than or equal to little y. For some reason, people seem to have a problem with the definition of distribution function. The definition is just this, there's nothing more complicated than that. The distribution function of this random variable is a function, right? So you evaluate it at a point. At this point is the probability that this random variable is less than or equal to 1. So this is probability that log x, so you want to write everything in terms of x, let's solve it, so x has to be less than or equal to y. Now you've got probability that this random variable is less than or equal to some number, and that is just the distribution function of x at this point. So now differentiating both sides, you get the density function of random variable y at this. So this is capital Y, this is little y. Is when you differentiate this with respect to y, you first get this density function of x at this point times the derivative of e of y. That's just a chain rule. If you want, you can stop there, or if you want, you can actually write it out. Density function of your random variable y at the point that y is e to the y times the density function of x at e. So 1/8 4 minus x is e to the y. And this is when your e to the y, right? Well, it's for y in that range. Okay, so the negative infinity. So take log x as x goes to 0. As x goes to 0, what does log x approach? What's the graph of log x look like? Graph of log x at x equals 1, log of 1 is 0. Okay. Something like that. That's your graph of log x. Okay. So as x, so this is the graph, this is x, this is y-axis. As x goes to 0, log x is dropping down to negative infinity. Any questions about any of these problems? Okay, so I'll give you a few more minutes to look through your exams, and if you have any questions, ask me before you leave class today.
Is this on a normal grading scale?
Do you mean normally distributed?
Yeah.
Something.
I haven't checked if the scores of this class were normally distributed, but I did come up with a cutoff.
Oh, he was being serious. We talked about it anyway. That wasn't funny.
I don't have it with me right now, but I can email you guys the code, the cutoff for different grades.
Screwing up the curve.
Yeah, I don't have it with me right now. Yeah, but I'll email you guys and let you know what the code looks
I'm
like.
just laughing. I'll bet you want to. Yeah, good enough. I'll live. I'm not going to be looking for any tall buildings over the night. I thought I was going to be more.
Your x is equal. Well, have seats in the flight, you don't know what the distribution of that is. All you can say is how many people show up or how many people don't show up. So that is find from what the distribution of this is.